Let's take a look at an old midterm exam question. We're doing this just to give you more practice manipulating tables using multiple table methods. Here we go. Each row of the trip table from lecture describes a single bicycle rental in the San Francisco Bay Area. Durations are integers representing times in seconds. The first three rows out of 338,343 appear below. Write a Python expression below each of the following descriptions that computes its value. The first one is provided for you. So you could say the average duration of a rental could be computed by setting the total duration to be the sum of all the durations, which we get by taking trip.column. Trip.column gives me an array. That array is summed to get the total duration. The average duration is the sum divided by the count, the number of rows. When I wrote this midterm, I also asked students, compute the name of the station where the most rentals ended, and the number of stations for which the average duration ending at that station was more than 10 minutes. Take a few minutes to see if you can figure out how to solve these problems in 2 lines or less. Feel free to pause the video if you want to work on it for a while. We'll go over the answer together in 3, 2, 1. Here we go. Here's the table. In fact, I took the original data set that I found online and removed everything that was over 30 minutes or 1800 seconds, and then selected only the columns of the starting terminal, the ending terminal, and the duration of the ride. Each row is a single bike share rental. So the name of the station where most of the rentals ended means that I need to figure out how many rentals ended at each station. Trip is the name of the table. Group is the method that will allow me to count how many times each ending value appears. End is the label of the column that I want to group by. I do not need to add an aggregation function because I just want the count of how many trips ended there. Now I'll be given a 2-column table where each terminal that ends any bike ride appears once, and then the count of the number of trips that ended there appears as the second column. So I'd like to find the one with the most rentals, which means I'll sort by the count column in descending order. That means at the very top, there's the one that happened most. Now to finish this question, we have to see exactly what it's asking for. It's not just asking for a table with that one row. It's asking for the name of the station, which is a string. So I now need to get the row at the very top of this table and look at the item in column 0, which is the column that contains the end. When we run this computation, it will compute that San Francisco Caltrain is the station where most trips ended. In order to follow exactly how we got there, let's take a look at every intermediate result. This comment means that this part is not going to be evaluated. So what happened here is that I computed row 0 of a table that was already sorted, so that had the name of the station and also the number of bike trips that ended there. If I had not asked for the row, then I would get the entire table in sorted order. There's the one that ended most trips, the second most, the third most, the fourth most, etc. Before I sorted, I grouped. Now grouping does sort, but not by the count. Instead, grouping sorts by the value that you're grouping on, namely the name of the end station. So alphabetically, second at Folsom is first, which is why it appears at the top. But this is not an interesting order for the question we're trying to answer. Instead, we have to sort by the count and then get the value at the top. And then we're done. So I could have built this up step by step, running each step in order to verify the result is what I expected. But instead, if I really understand how group works and how sort works, I can just write down the whole expression and trust that it's going to compute the result accurately for me, then I'm ready to move on. Okay, the number of stations for which the average duration ending at that station was more than 10 minutes. I'm going to need to work with the end station and the duration. I'm going to group by end again, but this time I'm going to have to aggregate the duration values for all trips that end in the same place. A good place to start is to just drop the start column because we don't need that. Now we're ready to group. We'll group by end to make sure we have one row for each end station. But now I want to say, what am I going to do with the other column, the duration column? I'm going to average it. I'm left with a two-column table that has end as its column 0, and then the average duration as its column 1, which means that I can use the average duration to decide which stations have the property I'm looking for, that they are above 10 times 60, or 10 minutes times 60 seconds per minute in average duration. Now I have a table of all of the stations of interest, the number of stations I get by figuring out how many rows there are in that table. 21. Let's trace how we got to this result. I built a table that only has rows for stations that have a long average duration. There are 21 of these out of how many stations were there originally? Well, there were 70 stations, the 10 here plus 60 more, but they had some averages that were below 600. Here's one at 530, so here's one we keep, and a bunch of these we don't keep because they had average durations that were really short. Most of the work was in computing this result, where we took the average duration. The only thing we did before that was to limit ourselves to just end and duration. Now imagine we hadn't limited ourselves to end and duration, and we had just grouped immediately. Well, that's not wrong, but it's really hard to average a bunch of start location values because they're not numbers. So here we'd end up with this blank column. That was confusing, so the way we fixed that was just to drop that column and then perform our group. A general strategy for solving problems like these is just to think about what options you have available and then write out a little sketch of the intermediate result after each method call so that you know what you're working with when you apply the next method.